In our last section in this chapter, we're going to discuss a few different kinds of circuits. Now, I do want to mention that your book has a whole lot of symbols and a whole lot of math in this particular chapter that we are not going to get into, but there are a couple of symbols that I do want you to be aware of. One is the symbol for, I've already taught you the one for a battery, and there's also one for a switch. And a switch basically just looks like if you've taken this circuit and you don't have it completed, and you've got this little metal piece coming out here like this, this is considered the symbol for a switch. So this is supposed to be a light bulb. And so in this particular case, you can see my battery right here, and you can see the wire not making a complete circuit. And so because the electricity can't get all the way from the negative to the positive, there's no way for the electrons to flow. So that means that this light bulb will not light, and this is called an open circuit. On the other hand, if I take that little piece of metal and I shove it back in, then everything would be completely connected. The electrons would be able to flow, and this is called a closed circuit. And here my light bulb is going to light. This is actually a circuit board that my daughter built for a 4-H project at one point. And in this, you can actually see the switch is right here. So I've got my batteries, I've got a couple of light bulbs here, and right now my switch is open, and so that means that the current is not able to flow. If I take this and I actually close the circuit, then the light bulbs will light up, and the current will be able to flow, and they'll work. Okay? There's a couple of other types of circuits that I want you to understand as well. If I had 2 light bulbs and I put them basically on the same wire, this is called a series circuit. Now, the problem with this type of circuit is that what can happen is if one of these light bulbs burns out or something otherwise goes wrong with it, then if this light bulb can't have current running through it, that means it's going to break the current for the whole circuit. So if this light bulb is broken, this one won't work either. And so that's one problem with the series circuit, is that unless all the light bulbs are working, none of them are going to work. A parallel circuit bypasses that problem, because what it does is it gives the current 2 paths to flow in. So as you can see, I've got wires going, a wire going across here and a wire going across here. Now this is the common way to diagram a parallel circuit. So here's my battery. The current can run around this way. It can also run around this way and take the longer path. So if everything works well, then both of the light bulbs will light up. If this light bulb gets broken, this one can still light because the current can go this way. If this bulb gets broken, this light bulb can still light because this one can go this way. And actually, that is what my daughter has built here, is a parallel circuit. And so you can see that if I take this bulb and I unscrew it, this one isn't lit, but this one stayed lit. And I can do it the other way too. I can unscrew this one, and this bulb is now not working, but this one stays lit. So that tells you that I've got a parallel circuit here. So there must be 2 complete paths for the electricity to go through. If it was a series circuit, if I unscrewed one, then neither one of them is going to work. So these are the types of circuits that I expect you to know. I expect you to know the difference between an open and a closed circuit. And I expect you to know the difference between a series and a parallel circuit, and why you would want to use a parallel circuit over a series circuit, what the difference is between the 2 of them.